Okay, guys, our third lesson is talking about the circulatory motion and how the object is moved in a circular path. Um, let's start. Okay. What is the angular displacement, guys? Angular displacement, we know before that there are two systems of measurement. One of them for an object that's moving in a circular path, and the other one for a linear displacement. Here today, we're going to compare between both of them, making a relation between both of them. What is the angular displacement? Let's first remember what is the displacement, linear displacement, velocity, and acceleration. Okay, need a white page, just a minute. Find the white page. We can use this part. Okay. What is the displacement? Displacement is the movement of an object from one position called initial position to another position called final position in a straight line. This one is called linear displacement. And the distance can be measured. The distance of displacement can be measured. Displacement equals if this point called xi and this one is called xf, so it will be xf minus xi. And the measuring unit of this displacement is meter or kilometer. If you're going to find the change, the rate of a change of linear displacement, the displacement by time, it will be called velocity. What is velocity? It's the rate of a change in displacement, the rate of change in displacement over change in time. So we can calculate it x minus xi over change in time, the period of time needed to make the change from xi to xf. And the measuring unit of velocity is meter per second. What is the acceleration? Acceleration is the change in velocity over time. Change in velocity, that means vf minus vi over change in time. And the measuring unit will be meter per second square. All of these terms are called linear motion. A motion which is presented in a straight line, even to be displacement, velocity, or even to be an acceleration. Today we're going to study the angular one. Angular one means the movement of the object, the movement of the object at which is called curved path, circular path. We know that the circle consists of an angle, total angle of 360. So we can divide it by different sizes, depending on pi over 6, or even to find the total angle of the circle, which is 2 pi. Pi here is equal, pi here is equal 180. So 2 pi, it will be 360. Okay. 360 degree. Any measurement of any angle is measured in degree. So we can measure this angle in degree. This angle is called theta, and the angle is measured in degree. This angle is theta, another one, and it's also measured in degree. This one in degree. But if we need to find the displacement, this arc, we have two ways. Let's say this one. Okay, we're going to draw a circle. Here's the diameter, and here is another diameter. It's not a circle at all. I will prepare it. Clear drawing. I will draw a circle. Not a circle also, but I hope to understand. Okay, this one, this arc represents 1/4 from the circle. If we're going to find the length of this arc according to the linear motion, it will be 1/4 of circumference. To find the distance, 1/4 circumference. To find the just a minute. Where is this one? Okay. Okay. If you need to measure this hypotenuse, we need to use a displacement and Pythagoras rule. For this one, and we need to measure the distance by 2 ways. Or this one, let's say this part, this arc. You have two methods. One of them is by using the linear measurement, and the other one by using radian measurement. Linear measurement for using meter and centimeter and meter per second square, while radian displacement or radian measurement to use degrees. Here, for this arc, here, this one I need to change the color. For this one, for this arc, you can calculate it by 1/4 circumference, as it represents the linear distance, or to measure it using the angle to find the radian measurement. Angle here is 90 degrees, so theta is called 90 degrees. To find the displacement using radian system, you're going to remove the degree sign and put radian, RAD. So when you see this value, including this including this measuring units, so you know that it presents theta, but here theta is not an angle, it's called a radian displacement. Okay, is it clear? Okay. So first thing, we have something called radian displacement. A radian displacement equal to the angle itself. So the angle here is pi/6. Theta equal pi/6 degree, and theta also equal pi/6 radian. Radian here represents the displacement. And you know, guys, if you're going to change how to find the velocity, you will say that velocity v is equal distance over time, or displacement over time. That's in the linear system. To find it through a radian system, we call velocity omega. So omega is called a radian velocity. Here, omega is called radian velocity. As a linear velocity, exactly. Velocity is equal change in distance over time, change in displacement over time. Here, we can call it change in the linear displacement, which is delta theta over delta t. Delta theta over delta t, change value of displacement over time. If you need to find the acceleration in linear system, you're going to find the change in velocity. So you're going to say Vf minus Vi over time. For radian system, we call acceleration alpha. So to find the acceleration radian system, alpha is equal, alpha is radian acceleration. And this acceleration is equal to change in velocity, Vf, not V here, omega f minus omega I over change in time. Omega here represents the final angular velocity, initial represent initial angular velocity at the time. That's our lesson, guys. So easy and so too short. Too short. ماشي. Need to stop annotating, stop sharing. I need to share again, sorry. Okay. Let's fill in this table. I need to fill it because it represents the relation between an angular displacement and the linear one. And the angular velocity and linear one, angular acceleration and the linear one. The symbol of linear displacement is called x. Sometimes we call it d, no problem. Doesn't differ. خالص يعني. Angular displacement is called theta. Theta is the angular displacement. The relation between them, x equal r theta. So the change from the angular displacement system or the angular system to linear system, you have to multiply the angular value by r. R here is the radius. R here is the radius. The velocity is measured by meter per second, distance over time. We can change d by x, no problem. The angular velocity is called omega, which is equal to theta, change in theta, over change in time. And also to find the relation between them, so it's so easy. The linear velocity equal r times omega. R represent the radius of motion, circular motion, and omega is the angular velocity. Acceleration is, our linear acceleration is A equal Vf minus Vi over time. To find the angular one is called alpha. Alpha is omega f minus omega I over time. And the ratio between them is A is equal R times alpha. The measuring unit of angular displacement is radian. The measuring unit of angular velocity is radian. We can write it RAD only per second. And the radian of the unit of, so why am I writing it here? I should write it here. Okay, I'm going to make an arrow. Radian by second squared. This one represent, this unit represent the measuring unit of theta, which is angular displacement. This one is the measuring unit of velocity, angular velocity, and this unit is the measuring unit of angular acceleration. Okay? It's okay. The last part in our lesson is what is the value of frequency? Frequency is the number of repeated circles in certain times. So we can find it by omega over 2 pi. Omega is the angular velocity divided by 2 pi. 2 pi here represents the total angle of the circle. The total angle of the circle. So you can find by this way how many times a complete circle repeated in 1 second. A complete circle repeated in 1 second. Okay, guys, study well this lesson. Give me 1 minute to start solving a sheet for this lesson. Okay, guys, here is your third homework. I need to solve it with you. Explain the difference between angular displacement and angular velocity. What is the difference between them? Okay, we said that the angular displacement is the change in location, by an angle, and to find it is called theta is the same value of angle represented in radian instead of degree. And the angular velocity, while angular velocity is the change in angular displacement by time. What is the angular displacement of a region of a wagon that moves 135 around the circular mass? You need an angular displacement. Here's the theta. Theta is 135 degree. It's an angle. So theta, which represents the angular displacement, is equal 135 instead of degree going to right radian. A playground merry-go-round makes 2 complete rotation in 9.6 seconds. What is its angular velocity? عايز الانgular velocity. طيب الانgular velocity, guys, is theta over time. It makes okay. So theta here, theta is equal to the displacement. Theta is the angular displacement. To find the value of angular displacement, you have to find the theta itself, the angle itself, then removing a degree sign to make it radian. What is the value of the angle? 2 complete rotation. 2 complete rotation represents the angle. So theta, the angle, is equal to 2 multiplied by 360. So it will be 720. 720 is the angle itself. So also displacement equal 720 angular displacement region. To find the velocity, omega, 720 region divided by time. Time is 9.6. So the value will be just a minute. So it will be 75 region per second. Okay, guys. For the fourth question, did you calculate an average angular velocity or an instantaneous angular velocity in the previous question? In the previous question, we found the value of total theta. Theta here is called the angular displacement. يبقى total distance or total displacement over total time is called average. It's called average displacement. It's called what? Average displacement. So we found in the previous example an average displacement. I think the next one is the last question. The last question. A car increases its angular speed from 2 pi over 3 to 3 pi over 2. Omega I is equal to pi over 3. Omega final is called 3 pi over 2. The time is 5 seconds. We don't have any change in measuring units here. Here region per second, and also here is region per second. Alpha is the angular velocity, is equal 3 pi over 2 minus 2 pi over 3 divided by the total time, which is equal 5. So the angular velocity will equal to 0.523 region per second squared. Okay, guys. Thank you for listening and study well.